Good day everyone. In this short presentation, I'd like to give a brief overview of the status and future of wind, solar and storage and the promise of superpower. There are no panaceas or silver bullets to the problems of climate change, but I hope to convince you that wind, solar and battery storage can play a major role in our transition to a low-carbon, sustainable energy world. Energy drives development and underpins modern civilization. Here we have two well-known composite nighttime images that are dramatic illustrations of this. On the left is North Korea and South Korea, and on the right we have an image of the whole planet. There is a strong correlation between light, state of development, and economic activity. If we want to power progress and human development, what can supply the energy? At the top left here, the orange circle shows the global annual energy requirement as it stood in 2015. The big yellow circle is the annual solar energy supply, with the rest of the renewable energy sources also indicated. The circles to the right show the total known supply of non-renewable or fossil fuel sources. These are finite resources that will run out. This image provides the answer to an interesting theoretical question. How much of the planet's surface would need to be covered with solar PV modules if we wanted to power the world's full 2030 energy requirement with solar PV alone? This green square to the left here is the projected global total energy requirement in 2030, and the smaller green squares distributed across the world map illustrates what this could look like in practice. The bigger square, this one in the Sahara Desert, is 1/4 of the overall requirement and is 18 times smaller than the total Sahara Desert area. Consider also that solar PV efficiency has improved by about 30% since 2008, meaning that the green squares should shrink by 30%. This is not at all to say that it should all be powered with solar PV. It's just an illustration to give a feel of the scale and what's possible. There's an urgency to the transition to renewables. Here are just two graphs showing the reality of climate change. On the left we have incidents of extreme weather events since 1900, and on the right is temperature deviation from the 1880 to 1900 baseline average. But energy is not just about climate, of course, it's also about cost. Here we can see how the price of solar PV modules has declined dramatically by 99.6% since 1976. This graph shows the change in levelized cost of energy, in other words, all-inclusive cost of energy, in dollars per megawatt hour over the 10-year period 2009 to 2019. Note the dramatic reductions in cost of solar PV and wind over this 10-year period. Here's another graph showing the reduction in cost versus cumulative installed capacity on a log-log scale. This is also known as the learning rate. Again, as you can see, there's been dramatic reductions for solar PV and onshore wind, whilst coal has stayed at approximately the same price, and nuclear has increased substantially due to factors such as stricter regulation and nuclear build cost overruns. The numbers indicated here are global weighted average costs. If we look at world records for solar PV independent power producer sales to utilities, the 2020 world record was $13 per megawatt hour in Portugal, and the 2021 world record was $10 per megawatt hour in Saudi Arabia. That's an unbelievable $0.01 per kilowatt hour. It should be noted that the renewable prices do not include storage, of course. If storage is included based on 2021 prices for wholesale PV plus lithium battery storage, this is the price range in green, based on Lazard's most recent levelized cost of storage report. So it's already competitive with coal and nuclear. At the same time as cost has been decreasing, efficiency has been increasing. The blue line here depicts the world record solar PV cell efficiency from 1976 to 2019. It's interesting to note that the best photosynthetic efficiency achieved by plants is about 4.3%. This means we have already managed to improve on the best of more than 3 billion years of organic evolution by a factor of 10. The best commercial solar PV efficiency was 22.8% in January of this year. The message here is that there is still lots of room for further improvement. The efficiency and cost improvements haven't come from one big breakthrough, but from many incremental improvements. Some technologies have already become mainstream, such as half cells and PERC, or passivated emitter and rear contact. Perovskite is expected to become commercial by 2025 and promises to take efficiencies to over 30%. A bit further down the line are multi-junction cells and quantum dots. The quantum dots are applied in a film on top of a standard silicon cell. Quantum dots shift wavelengths so that more of the light is in longer wavelengths that are better absorbed by the silicon layer. Looking at wind, there has also been large technological improvements in the past decade. Taller and larger blades are leading to improved capacity factors. In other words, they produce energy more consistently or for a bigger percentage of the year. Whereas solar has a maximum capacity factor of about 25%, in other words, it generates energy for about 25% of the day. Wind can get to over 60% in some regions through very tall turbines. For example, as depicted here in this diagram for the USA, for 140-meter tall turbines, just about 2 million square kilometers of the USA has the potential to have capacity factors of over 60%. And the turbines continue to grow taller. This is just to give you an idea of the scale of the blades versus a human, some specimens of which you can see in the bottom right. This turbine blade is over 100 meters in length. If we look at battery storage, we see a similar trend to wind and solar PV. The price of lithium batteries have fallen by 97% from 1991 to 2018. The technology improvements behind this dramatic price decrease were driven initially by the mobile phone industry and now increasingly also by the electric vehicle industry. Here are just a few key battery technology trends. Grid parity for solar plus storage has already been reached in some European countries and is projected to be reached for most countries before 2030, including countries like South Africa and India. There's a trend towards safer lithium iron phosphate batteries, whilst flow batteries have potential in longer-term stationary storage, specifically for utility-scale applications. Other new and emerging battery technologies include solid-state batteries and inexpensive sodium-ion batteries. Lastly, I would like to quickly introduce the concept of superpower. When sizing solar PV and wind to cover 1 times the total energy demand, very large storage is required, as is depicted here at the left axis, where the generating capacity of solar PV and wind matches the demand. Due to the higher cost of batteries, the minimum total cost is not where solar and wind generating capacity matches demand, but at much larger generating capacity. In other words, supersizing the generating capacity and reducing the battery storage. Clean energy superpower, in other words, so-called overproduction of energy that can't be used immediately, is a solution, not a problem that needs to be curtailed. The superabundance of near-zero marginal cost electricity that results from clean energy superpower will have a transformative impact on energy markets, energy-related and energy-intensive industries, and the economy as a whole. Just like the information revolution brought near-zero marginal cost information, and this enabled radically new business models. The applications of superabundant near-zero marginal cost energy will enable the emergence of new paradigms and business models across a wide array of industries. Applications include electrification of road transportation and heating, water desalination and treatment, waste processing and recycling, metal smelting and refining, chemical processing and manufacturing, cryptocurrency mining, distributed computing and communications, fuel production, and carbon removal, just to name a few. To summarize, wind, solar, and battery storage costs have fallen dramatically over the past few decades, and this trend seems to be continuing. There's still many things to figure out, and a careful transition is required in order to minimize cost and maximize benefits to the world economy and human livelihoods. But this clean energy troika can surely support a faster transition to a low-carbon, sustainable energy world than previously imagined. Thank you for listening.